Chapter 8, Section 4 is about angles of depression and elevation. So by the end of this lesson, you should be able to solve problems involving these angles of elevation and depression. So what exactly are they? So an angle of elevation is the angle formed by a horizontal line to a point above the line. So if you're sitting in this tower, this is your regular horizontal line of sight. If you look up at something, you just created an angle of elevation. Where if you're in this plane, this is your horizontal line of sight. If you're looking down at the tower, this is your angle of depression. So both of these lines of sight are horizontal, and we know any horizontal line is parallel to another one. So if we treat this line of sight as a transversal, these two angles here have to be congruent by the alternate interior angle theorem. So therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. So let's classify each of these as an angle of elevation or an angle of depression. So angle 1. If this is our original line of sight, and then they make an angle like this angle right here is depression. It's down from the horizontal one. Where if we look at angle 2, this is my original line of sight, and then I'm looking up at something. So this angle right here is elevation. And then if we take a look at angle 3, this is my line of sight again, and I'm looking down at something. So this angle here has to be depression. And I know it's not on here, but if we look at angle 4, my original line of sight, again, is this horizontal one right here. So I'm looking up. So this angle right here has to be elevation as well. So let's do some problems. The Seattle Space Needle cast a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Rounded to the nearest meter. So we have the Space Meter here. And it casts a shadow that is 67 meters long. So you have 67 meters here. And then the angle of elevation, so if this is my line of sight when I'm looking up, is 70 degrees. I need to figure out this length right here. And then we assume this makes a nice perfect 90-degree angle. And we can use our trig functions. So in reference to this angle, I need to do something with the opposite and the tangent. So SOHCAHTOA tells us that we're going to use tangent. So if I take the tangent of this 70 degrees, that's equal to the opposite that I don't know, divided by, oh, this shouldn't be 67 degrees, it should be 67 meters, divided by 67. And remember, the tangent of 70 is just a number. So x is 67 times that number, times the tangent of 70 degrees. So if you go and type that in your calculator, you end up with 184 meters. And that's how tall the Space Needle is. Let's try another one. An ice climber stands at the edge of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevice at this point? Round to the nearest foot. So you're at the edge of this crevice. You're standing here, and this crevice is 115 feet wide. And then it says the angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. So if we draw this angle here is 52 degrees. And then, again, we assume that this makes a nice 90-degree angle. And we can figure out how deep it is if we find this distance right here. So this is what we're looking for. So we, again, take a look at our triangle. We have stuff on the opposite side and the adjacent side. So just like before, we're going to take the tangent of 52 degrees. and that's going to be what we don't know over 115 feet. So again, we can manipulate this before we type it in our calculator so we don't have rounding issues. And then when we type this in, you end up with a nice 147 feet. So let's say an observer in a lighthouse is 69 feet above the water. He sights two boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees, and the angle of depression to the other boat is 22 degrees. What's the distance between the two boats? All right, so we have this lighthouse, and the person sitting in here, they are 69 feet above, and then we have the water, and we got two boats out here. And it says that the angle of depression to the nearest boat is 48 degrees. So remember, his original line of sight would be right here, this horizontal line. And remember, that is parallel to the water here. And then angle of depression is the 48 degrees. So when we do this down to the nearest boat, this is 48 degrees. Now remember, that also makes this guy here 48 degrees. And that's useful because what we need to find is the distance that is right here from the lighthouse to the boat. So we can see that this makes a nice little triangle here. So again, we want to find opposite and adjacent, so lots of tangent stuff. So we want to take the tangent of 48 degrees is the opposite, which is the 69 feet, that's how tall he is, over the adjacent, what we don't know. And if we rearrange this, multiply both sides by x and then divide by tangent, we get that x is 69 divided by the tangent of 48. So when you go and you type that in your calculator, you end up with about 62.1 feet. So now let's do it for the other boat. The further boat is 22 degrees. So this right here is only 22 degrees. And remember, because these are parallel, that makes this angle 22 degrees as well. And then again, we have this nice pretty triangle right here. And this time we want to find this whole distance down here. So let's call that a different letter. Let's call it y. So again, we have opposite and adjacent. So we're going to take the tangent of 22 degrees is 69 over the y that we don't know. And if we rearrange this, we get 69 over tangent of 22. And if we plug that in our calculator, we get 170.8 feet. So remember, the whole goal of this problem is we eventually wanted to figure out the distance between the two boats. We want this distance right here. So what I'm going to do is just subtract 170.8 minus the 62.1. And then if we round that to the nearest foot, you end up with 109 feet away from each other. And this is as hard as these problems will get, but basically it's just an application of the trig functions where you have to draw in your own picture. So you should be able to solve problems involving angles of elevation and angles of depression. Make sure you write down any questions you have and we can go over them in class. Have a good night.